Alright, only one bell word question today. So we want to name any properties used. I'm going to do the parentheses here first. I like this bell word question because there was quite a few problems in yesterday's assignment with fractions. Well, with division signs that I wanted you to write as fractions, so we'll talk about that. Now we'll do this set of parentheses, the division first. There you go, there you go. I'll keep it going. Yeah, let's go ahead. And so our fraction looks nice. Here, make them both look like fractions. Let's do 1/4 times 4/1. So really, I've done two properties in that step. This one is the identity property. Identity property of multiplication. Three times 1 is 3. And 1/4 times 4/1, that's multiplicative inverse. Cancels out to be 1. One plus 3. Final answer 4. Questions? All right, who named both properties correctly? All right, very good. All right, that's it. Let's just go over homework. I would say that this was kind of a long assignment, honestly. You really showed all your work. How many did I get through in class though? I went through like 4, didn't I? I went over to 8. Yeah, 4. I want to have all these answers. I think number 2 in the class. Alright, you guys compare answers together. Now some work. So that was 1 through 8. Here's number 9. Check yours. And number 10. If you did not do properties, put them in now. There's 11 and 12. There were some groups where I'm looking and both people in the group have it wrong. So this is your chance to really check, make sure you guys got it right. 11 and 12 are both 1. I love 11 and 12 because a lot of you, I don't know. I should have looked at 11 and 12 too, honestly, because I love to see you taking this division and writing it as a fraction. If you didn't, consider it. If you put like 1.3, who's got a decimal here on number 11? Anybody raise your hand if you put a decimal? Did you put 1.3? Yeah, 1.3. And then, yeah, you put it. So just take a look. Sometimes fractions are better than decimals. And the decimal's great. Hopefully your problem worked, but sometimes you'll end up with a decimal in the end, whereas if you would have taking your division and written it as a fraction, you get to use that inverse property and it cancels. So again, look at 12 and see the opportunity to write it as a fraction and then use the inverse property. So as you're seeing those division signs, I want you to really think, well, maybe this works best as a fraction. So I wanted to highlight 11 and 12. And 13 and 14, I walked around and discussed with most of you. And feel free to take a picture of the screen if you know you need to go back and redo them. Say, Miss Holland, can you show 11 again? And you can get on a device and take a picture. That's okay. And then 15, I started out doing properties, and then I said, you know what, this is too complicated. Let's just use the calculator. Alright, that's it for checking homework. We're going to do a couple of notes on distributive property. So you're going to put this in your notebook right underneath your homework. Or no. At this point, it would be underneath bell work. So underneath bell work, you're just going to write some notes. Let me get them up here for you. Keep your homework until you go to your funeral. I don't know. Keep your homework for a while. This until old age. Until you graduate. Keep it, keep it. I say keep your homework. I would say till the end of the chapter. Right, and then you could study it if you wanted to go back and study it. But then I think, there's going to be a midterm exam. Maybe you want to see it then. And then, what about the final? Maybe you want to go back to this assignment for the final. I don't know. I am not going to look for it anymore. I am not going to look for your assignment anymore. I've graded it. Now, maybe, oh, no, this is for real. This is the real answer. I don't know why I've been talking about it. Definitely keep your homework until there's been a grade posted in Focus, right? You want to see that you got 100% for the last 2 weeks before you lose that homework. Because what if I don't give you credit? You can be like, Mrs. Belvin's right here. Where are you at? So keep your homework until the grade's in Focus for sure. Here we are, chapter 1-4, the distributive property. Now we've talked about distributive property, but I haven't done a lot with it. So we're going to spend kind of the whole day on distributive property and combining like terms. You don't have to write all this. You don't. You can read it. You can shorthand it. You can think about it. I would love to see chapter 1-4 written down and the distributive property so you know where in your textbook to look. So we're going to rewrite expressions using the distributive property and simplify. Some of you have been using the distributive property, but today we're going to do it with variables. I'm going to put some x's in, some y's. So remember, combining like terms. So when you're combining like terms, you add coefficients and leave exponents the same. We're going to do an example, but I'll show you what I mean. These are like terms. They both have x. 5 x's and 3 x's make 8 x's, right? And 5x squared plus 3x squared makes 8x squared. We don't add exponents in this type of problem. That's what we're working on today. All right, here we go. We're going to distribute and then combine like terms. I think we have 3 problems that look almost identical. Remember when you distribute, I like to see arrows. So the arrows I really want to see is we're going to do 4 times 3x, and we're going to do 4 times 2. So distributive property, 4 times 3 is 12. The x stays. 4 times 3 is 12, and the x stays. 4 times 2 is 8. Now I stop distributing. I don't go beyond the parentheses. Bring the plus sign down, and bring the 7x down. I'm going to write my property. That was an example of distributive property. All right, so Joseph, what property do you think we're going to use next? Well, let's go ahead and pull a commutative property and put like terms next to each other. So let's go ahead and this isn't going to be required all year. As we move forward, you can kind of do this in your head. But I'm going to show the commutative property, and I'm going to put that 7x right next to its pal, the 12x, so that I can combine like terms. This isn't a property, but I'm writing it for your notes. Like terms have the same exact variable. I add 12 and 7 to get 19. Bring down the plus sign and the 8. We cannot go further. There's your final simplified answer for example 1. Okay, this one looks almost identical. What's the difference between number 1 and number 2, yes? Yeah, we have an exponent here. Let's see how that plays out. Let's see if that makes a difference. I'll give you time. Go ahead, distributive property, combine like terms. So we would need an exponent like first, right? Well, what can you do with that exponent? Yeah, we're gonna multiply the coefficients just like we did here, and just leave the x squared. If that x had been like a 5, then we would have done 5 times 5. X1 squared. But now, since we have a variable, we don't have that option. We don't know what x is, so we can't actually execute that exponent. So we jump right to distributive property. These problems are actually significantly different than yesterday's. What's the main difference between this and yesterday's? That's not it. That's not looking for yes. It actually has variables. So all week we've just been working with numbers. And now we have these x's and we don't know what x's are. So now we're just kind of simplifying. We can't actually do much with it. So now I'm going to distribute. I only distribute into parentheses. 4 times 3 is 12. Exponent stays the same. 4 times 2 is 8. Bring down the plus sign. Bring down the 7x. What's next? Commutative property to put in standard form. There are no like terms. So I'm going to put this in standard form. Standard form puts the x's in order. I could put 12x squared plus 7x plus 8 is standard form. And then I'm going to box this. There's actually nothing else we can do. You cannot combine an x squared and an x. You stop there. If it was multiplication, we could, but you can't add these. They're not like terms unless the exponents are the same. terms if exponents don't match. Can't do it. Okay, this next one looks almost the same. Let's see. Distribute, combine like terms. Draw your arrows and multiply in. Boy, these are looking really similar. What's new about this problem? Anybody? Yeah. There's another exponent. Yeah, now the term at the end has an exponent. Let's see how that changes things. All right. So again, we're just doing the 4 times the 3, and the x squared stays. 4 times the 2, we get 8. Bring down the plus sign, bring down the x squared. Now, I want to put this 7x squared next to the 12x squared. That's that commutative property. And this time we do have like terms. So we're going to combine these by just adding the coefficients. Coefficients are the numbers in front, not the powers. Adding coefficients gives us the result of 19x squared plus 8. And that's simplified. Okay, here's a little note in orange. Who can read for me the note in orange? Go ahead, Jacob.
Sometimes you can distribute to the left.
Yeah, sometimes distributing to the left makes sense. So this can be difficult to see. This time the number that we're distributing isn't here. It's over here. So that's okay. I'm going to draw arrows the other way. So here I am on this little star here. Sometimes we distribute the other way. I'm going to do 2 times 5, resulting in 10x. 2 times negative 10, negative 20. So this time I'm multiplying left. 2 times 5, and I write it. 2 times 10, and I wrote it here. Wrote it over here instead of underneath. Okay. The other thing you're going to see in this section is reading words and writing expressions, which we started out doing. We started the chapter with. But now it's a little bit more complicated. Try to read this. 4 times the sum of 2 times x and 6. Try to write that down using parentheses. Okay, write the problem using parentheses. Does anybody need me to go back? Yeah. Sorry. Going too quickly. Who prefers math problems with variables? Yeah, I mean, honestly, we're actually like simplifying less than those problems you did yesterday, because once those x's are in there, you can't combine much, you know. So they're actually shorter. Just gotta get used to them. So 4 times. See 4 times. Maybe you start with a multiplication dot, 4 times. And then I see the sum of. So that means I'm going to be doing some sort of adding. Sum is adding, right? Sum is adding. So the sum of 2 times x and 6. So this is my and right here. 2 times x and 6. So I'm supposed to do 4 times this sum. 4 times all of this. So that's where I want my parentheses. 4 times the sum of 2x and 6. So this is the wording of a distribution problem. You have to figure out how to put the parentheses around that quantity and then distribute. So this was the problem. It says write the expression, then simplify. So to simplify, we'll do the distributive property. We're going to do 4 times 2 is 8, keep the x. 4 times 6 is 24. And it turns out that 4 times the sum of 2 times x and 6 actually looks like this in the end. I'm going to try this one. You guys can talk about it in your groups. That's number 6 in your notes. So discuss this one in your groups. I'll give you guys a minute. See, I'll walk around, see which groups can come up with it.
Well, quotient means division, so anything that
Oh, I see it. That's what
and
that is.
hoping.
Like, how do we write that out? Or do we not have to? B. That actually might be. Look, how do we write out what? Oh, yeah. Oh, wait.
I don't think anyone's going to get it.
Yeah. 1/2.
I don't think anyone's going to get it, to be honest.
Yes. Oh. Finish.
Good try, good effort. No, good try. No, that's what everyone's putting the same thing.
Alright, we got it. We got it. We got it.
Also very close.
Yeah.
It is challenging. I mean, Okay, let me just do it. The key is where it says the quantity of. Wait a minute.
No. Two times 4x.
Quotient. The other Q word.
Wait.
This would also be correct.
We did that so right. There was definitely no way.
Oh, I meant 3. I meant 3. So it is right now. I changed it.
Wow, that's really blurry. I don't know why that's happening to my picture. Whoa, I did it. Okay, this is number 7, not number 11. Again, I'll give you a minute to do it in your groups. Oh, the answer's there.
Yes,
But no, but the writing the problem isn't there. So let's see if you can write the problem. See if you can figure out how to write a problem down for the way that's described. Margaret uses dots to track her activities on a calendar. Okay, Margaret. Okay, nobody does that. Okay. Maybe you do. Maybe you do. Okay. Red dots show homework, yellow show work, and green track. In 1 week. In 1 week, she does 5 red and 3 yellow and 4 green. How many activities does she do in 4 weeks? So I'm going to do 4 times 5 plus 3 plus 4. Oh! Yeah, right? So let's see if this yields 48. 8 plus 4 is don't do that. 8 plus 4 is 12. Okay, 48 activities. Margot's pretty busy. Did you put the variables in like I did here? Okay, that's it. That's it for me. You guys can start the